Winter officially arrived yesterday, though of course most of us feel like it arrived the middle of last week. But as we do every time a new season begins, we like to check in with our resident astronomer, Dr. Chris Palma from the Penn State Department of Astronomy and Astrophysics. He's also Associate Dean for undergraduate students in the Eberly College of Science. Good to see you again, Chris.
Thank you.
Lots to get to. I think we should first talk about the news out of Puerto Rico of the collapse of the Arecibo radio telescope. Just an iconic instrument, both scientifically and culturally. What's the reaction from your community?
Yeah, so we all know there's so much going in the world right now, and things are complicated. But even on top of all of that, this was a shock, right? I mean, I can't tell you. Looking at social media, for example, it feels like people are mourning the loss of a friend, right? This is a world-class scientific facility. It was doing groundbreaking research. And we just learned not long ago that it was damaged to the point that it was going to be decommissioned. But decommissioning it is different than it collapsing, right? This observatory, it played a huge role in our colleagues' discovery of the first planets known outside our solar system. It has radar capabilities, which is rare. So it played a big role in our understanding of the solar system with its planetary radar. And I've really seen, you mentioned culturally, that Puerto Rican astronomers in particular are heartbroken because this facility provided so many opportunities for science students in Puerto Rico to make major discoveries and launch their careers. So I'm really devastated by its loss.
And it's also been a part of several very famous movies. So Arecibo obviously led to a lot of interesting discoveries. I saw that one of your colleagues was recently involved in a discovery using a different instrument of sort of a missing link in star evolution.
Yeah. We've talked about this instrument before. This comes from the Habitable Zone Planet Finder that was designed and built here at Penn State. And it really is meant to study exoplanets, but it can do so much more. And this was a really fun story for me because I love to teach about stars, and I love to teach not just about like normal stars like our sun, right? We talk about how our sun is an average yellow star. There are some really exotic objects out there that have properties that are very hard to explain. And what I often teach my students is when you find something rare like that, we can often explain the oddities by proposing that one star transferred some of its mass to the other star, or perhaps two stars even merged. And so what was really exciting about this discovery is they got evidence that that is what happened in this really interesting case, that two stars merged and in that merger produced this gas cloud that they've studied in some depth. So really, really interesting discovery.
Yeah. And since we last talked, not one, but two asteroid related stories in the news. First, NASA landed a probe on an asteroid in October, and then this month a different probe actually returned to Earth with an asteroid sample. I mean, this sounds like stuff out of science fiction.
Yeah. And it really ties nicely to what we were just talking about, because I like to point out, right, we talk a lot about how astronomy is done by taking observations with radio telescopes or with optical telescopes of these distant objects. And we often talk about robotic probes that fly by Pluto, for example, but it's really rare to talk about sample return, right? I mean, if you think about it, the Apollo missions brought moon rocks back, right? So how many other times have we had the opportunity to actually directly examine on Earth material from another world? Not many. And so the fact that there are two missions bringing pristine asteroid material back to Earth, it's going to really answer a lot of questions for us about how the Earth formed. And in particular, it might tell us something about how Earth became to have so much water on its surface.
And the probe that returned the sample earlier this month was a Japanese probe. Then I just saw last week that a Chinese probe returned a sample from the moon. I mean, space exploration really is going global.
Yeah, it's both going global and we're taking some really interesting risks, right? Like think about how challenging landing on another object, scooping up material, sealing it and storing it and returning it to Earth is, right? And so it's great to see that the US and other countries are able to pull this off.
Yeah. I saw the latest round of Nobel Prizes. had a Penn State tie, not someone who's a full-time faculty member in your department, but rather a frequent visitor. Tell us a little bit about that.
Yeah. I mean, it's always exciting for me when Nobel Prizes are given in physics are for discoveries in astrophysics, right? and oftentimes those are things, again, we talked about exotic objects, right? So pulsars have been awarded 2 previous Nobel Prizes. So this was one for black hole physics, which is something Penn Staters are very interested in. And Roger Penrose, a well-known name in the field of black hole physics, has been a longtime visitor to the Institute for Gravitation and the Cosmos at Penn State. And I know so many students and faculty were really appreciative of all the time he spent here and all the lectures he gave and all the time he shared with us going through some really amazing cutting edge discoveries in black hole physics.
Yeah, that's just great. Congratulations. And we always like to finish. We have about a minute left by giving you a chance to talk about any celestial highlights coming up. I guess there's literally a big deal going on right now.
Yeah, I'm so glad to talk about this. We tend to talk about Jupiter and Saturn a lot at this time of year because they're often great targets to go see in the sky, but this year is really special. We've talked before about how the planets orbiting the sun, the inner planets go faster than the outer planets. Jupiter moves across our sky faster than Saturn does. And so it will appear to overtake it. And right now, Jupiter is passing closer to Saturn in the night sky than it has in centuries. Part of that is it's not just how close it approaches, but oftentimes when this happens, Jupiter and Saturn are on the other side of the sun from us. And so it would happen during daylight hours for us, so we can't see it. So it's the closest approach occurring at night near the solstice when we have the most hours of nighttime. So it's just an amazing cosmic alignment that happens at a great time for us to see it. So please go out and look for Jupiter and Saturn being really, really close together in the night sky.
Okay. Dr. Chris Palma from the Department of Astronomy and Astrophysics, thanks much. We will check in with you again in the new year.
Thank you.